Dear viewers, in this video, we will understand about another graphical representation in Minitab, which helps us to graphically analyze relationship between one continuous output variables and two continuous input or process variable. So the name of the chart that we are going to analyze today is contour plots. So contour plot is used to examine the relationship between a response variable, which will be in z-axis, and what would be the impact of two input or process variables, which will be in your x and y axis. So let's understand how does this graphical representation works. As I told, we are going to understand contour plots. So I'm going to click on graph. Before I do that, maybe I'll quickly explain you the data that I have. So I have a process where I am trying to create plates of steel. So the thickness of steel plates is my output parameter, and this thickness of steel plate is impacted by film density and tensile strength. So depending upon the film density and depending upon the tensile strength, when I use a particular input with certain film density and certain tensile strength, I get certain level of thickness. So this is the process for which we are going to draw contour plots. So I'm going to click on graph, and once I click on graph, I have my contour plot option here. I'm going to click on contour plots. So in a contour plot, you need to select three variables basically. So the z variable will be your output metric or output parameter. So here thickness is my output parameter, thickness of my film plate or metal plate. And my y variable, one of my input or process variable is film density. Another input or process variable is my tensile strength. So I select these two options, and now if I click on OK, I get a contour plot, and the contour plot looks like this. So how do we interpret this contour plot? So for us to interpret this contour plot, maybe we can select this particular option here. When we select this option, it gives us to move around this graph and understand how does it work. So here in my y-axis I have film density, and in my x-axis I have tensile strength, and the color of this particular graph tells me the thickness. So here you see an index where depending upon what color of green, how much thickness in millimeters can be achieved. So if I select this option and move my mouse pointer here, you will be able to see two lines. So the reason why I am selecting this is within my output parameter. So there are certain areas where I get a very high thickness. For example, if you see here, the spot here is where I get the highest of thickness. So if I want to achieve this thickness, that means greater than 2.4 mm, I need to maintain my tensile strength and film density. So if you see here in the top corner, you will find the value of x and y moving as I move my mouse pointer, and this movement of mouse pointer can be taken to whichever place inside this contour plot to identify the value of your film density and tensile strength, or in other words your y variable and your x variable. And if you see here, I am moving my mouse pointer to find out. For example, within my interaction between my tensile strength and film density, still I'll be able to get a spot here which gives me a better thickness of my response parameter compared to maybe somewhere here the thickness changes, but this is a spot, a good spot. Maybe this is where I can optimize my film density and tensile strength and still achieve a better result. Similarly, this is a spot where a value here tells me if I maintain my tensile strength and my film density in this spot, I'll still be able to get a better thickness. Whereas this is a weak spot. If my film density or tensile strength moves to this region, then the interaction tells me that my thickness drops or my thickness reduces, right? So this is how we will understand a contour plot. To make it easy for us to understand, maybe I can give you one more example. So here I have another data where I have the mass, that is a biomass, and the depth and cover. So depth and cover are my two parameters. And how do I get my biomass? Biomass being higher the better, and depth and cover are my two input or process variables. So in this example, I am clicking on graph again. I click on contour plots, and here I select biomass as my output parameter or my response parameter, and my input parameter will be depth, and the next input parameter will be cover. So this is on a different subject area where we are drawing the contour plots again. So now if you see this is another very good example. If you see here, I wanted to get a higher biomass. So again, I select this particular XY lines so that I would be able to understand this better. So if you see here, a very dark blue color indicates biomass being very, very low. And as it gets green, dark green, I will get a very high biomass. And if you see here, again, I can see a sweet spot here where I will be able to get a much better output response, and I can freeze this as my input variables and I can start my process. If I move out from this range, how does my output parameter changes, and what are the different areas at which what level of response parameter values I will be able to get if I maintain my input values at this given point. I maintain my input variable like cover and depth. So friends, I hope this video was helpful for you to understand. As I told in the beginning, I also uploaded a video on main effects and interaction effect. So that main effect and interaction effect plots are basically designed to understand the interaction effect between two discrete or categorical variables on a continuous output variable. So my output variable, my y parameter, is a continuous output variable, and my input variables are discrete categorical variables, and that's where we have seen in our previous video. Whereas in this video we understood how my output variable, that is my response parameter, being a continuous variable, and my input or process parameters are also continuous variables, and then we use contour plots as a graphical representation. In my upcoming videos, I'll also explain about some of the other graphs that we have in this particular category. For example, we have a 3D scatter plot and we also have a 3D surface plot. These are also two other graphical representation which helps us to understand the relationship between two input variables which are in continuous variables, and my output variable is also a continuous variable. So we will see how those graphs can also be used in our upcoming videos. I hope this video was useful. For more videos about Minitab tutorials, how to use tools, techniques, and graphical representations available in Minitab. As I was explaining in my previous video, I'm going to use the same set of data: thickness and film density and tensile strength. So in this process, as I was explaining, thickness is my output parameter. This is the process of making metal plates. So thickness of the metal plates is my output parameter or response parameter, which is a continuous variable. And my input variables or process variables are film density and tensile strength. So what is the role of film density and tensile strength in getting a required level of thickness is what we are going to understand using this graphical representation. So as I was explaining in my previous video, contour plots gives you an understanding of the same impact of film density and tensile strength. In fact, how is the interaction effect of film density and tensile strength is on your output variable called thickness of your metal plate. The same interaction effect is what we are going to see in this graph also. In my personal view, I think the 3D surface plot is a much better way of understanding this compared to contour plots. Both gives you the same information, but it gives you a relatively better understanding. So let's see why a 3D surface plot is a better representation. Let's see that. So I click on 3D surface plot. So here I can select two options. So let me first show you the surface plot, the simple one, and then I'll also show you the wireframe version of the same data. Okay, so I select this surface version and then I select OK. So here I can select thickness as my output parameter or response parameter, film density as my input parameter, and here I am selecting tensile strength as my second input parameter. So I click on OK. So the graph will be generated like this. Now if you see this graph, it may look difficult for us to understand. So let me tell you how to understand this graph. So in this particular case, we can understand this graph. So let me just a minute. Yeah, we can understand this graph by using this axis. So if you see here, your z-axis, the z-axis represents your output parameter. Your y-axis and x-axis represents two input parameter. So you can use these options here in your Minitab to rotate this graph the way we want. And this is to rotate it on the z-axis. This is to rotate it on your y-axis if you want to rotate it on your y-axis, and these two icons here is to rotate it on your x-axis. So for a better understanding, let me keep the graph in this particular angle so that we can understand this better. So here you have your film density, here you have your tensile strength, and as this is in z-axis, thickness, the third dimension is where you see thickness, and you see there are places where thickness is spiking out in the sense in between or in the x and y axis there are certain interaction areas where you have a better thickness, and you need to identify that better thickness, and that's when you will be able to do a better job in terms of optimizing your output. Maybe this is a slightly difficult view of this chart. You may find it difficult to understand how does this chart work, but what you can see here is these are points where when your tensile strength and film density have an interaction effect, you get a better thickness. So as I told, this might look slightly difficult for us to understand. We will convert this graph, or we will see a different version of the same graph. So what I do, I close this and I click on graph. I click on 3D surface plot. Now I select the wireframe version. Now I select this wireframe version and then I click OK. My other parameters are still the same: thickness, film density, and tensile strength. I click OK. Now I get a graph like this. Maybe this graph will be relatively easy for us to understand. So let's rotate this and get a better view of it. So I am using my XY axis rotation options to get a better view of it. Now if you see this at this point, these are places where there are some spike, but this is a place where you have a much better spike, and this is where you will be able to optimize thickness by controlling your film density and tensile strength. So you'll be able to rotate this graph the way you want and then have a view of what you are looking for, and this is where there is a much better interaction effect of tensile strength and film density. So what you see in a two-dimensional version in your contour plot, you will be able to showcase the same in a three-dimensional version. In contour plot, the third dimension, the response parameter, is actually explained using the color shade. The light or the dark shade of that color tells you how you are able to manage your response parameter. Whereas in this particular three-dimensional surface plot, you will be able to understand the impact of your input and process variable. In this particular example, it is your tensile strength and film density, how the tensile strength and film density is impacting the output parameter thickness. And if you see in this axis, it is very clear that if you want to achieve a higher thickness, this is the point at which you will be able to achieve a higher thickness, and this is where you have a good optimized interaction of your tensile strength and film density. So this was explained in the previous video, how it is the same concept is getting explained using your contour plots, using the color shade, the dark shade of the output parameter. In this example, we are seeing the same with the help of a three-dimensional chart. Friends, I hope this video was helpful in terms of understanding how to use surface plot to examine the relationship between a continuous output variable, in this case thickness, against the interaction effect of two continuous input or process variables, in this case which is film density and tensile strength. Hope this video was useful. For more videos on Minitab, tools, techniques, graphical representation, please subscribe to our channel. Thank you very much.